Our next presenter is Melissa Dawson. Melissa has been working as a structural engineer with WSP for 6 years. Melissa was heavily involved in the emergency response efforts for the Route 22 over Brook project, which is the focus of today's presentation. Please welcome Melissa.
Hi everyone, my name is Melissa Dawson. I'm a structural engineer with WSP, and today I'm going to be talking about the Hurricane Ida emergency repairs for the Route 22 bridge over Brook. So this is just an overview of the presentation. First, I'm going to talk about the Hurricane Ida impacts in the state of New Jersey. Then I'll talk about some of the existing bridge features and the storm damage that happened after the hurricane. Then I'll go into how we expedited and phased out the project delivery process, and then I'll get into our repair strategy. So Hurricane Ida was a deadly and destructive tropical storm that hit the New Jersey area on the night of Wednesday, September 1st, 2021. There were tornadoes in our area as well as flash flooding, and over 100 homes were destroyed in the state. It was also one of the deadliest storms in New Jersey since Hurricane Sandy. There was a death toll of about 30 in just a few days after the storm. And we actually had one fatality right at the bridge location where a woman was stranded in her vehicle right before flash flooding hit the area. The photo on this slide, the one on the top is Interstate 295 and Route 1, right by our Lawrenceville, New Jersey office, for anyone that's familiar with the area. And then the photo at the bottom of the screen is about a mile from the bridge location. That's TD Stadium in Bridgewater Township, New Jersey, and that was completely flooded out during the storm. This slide is just showing a map of the storm track and intensity of the hurricane. So it started in the Caribbean, and then it traveled up and along the east coast of the United States. And then the table on the right is the total rainfall in New Jersey during the hurricane for each of the counties in New Jersey. So the bulk of the rainfall during the storm happened over a 6-hour period, and Somerset County, where our bridge was located, received almost 10 inches of rain during the storm. So this is the project location. The bridge is located in Bridgewater Township, Somerset County, New Jersey. It's a single-span bridge, about 65 feet long, and it carries Route 22 eastbound and westbound, as well as a ramp to Route 22 eastbound that carries local traffic over the bridge. The ADT for the bridge is about 60,300 vehicles per day with 4% truck traffic, so it's a pretty heavily traveled roadway. And then the bridge is over Brook, which flows north to south. So south is the downstream side, which is where most of the damage occurred. At the southwest corner of the bridge is a car dealership, which was completely flooded during the storm. They lost a lot of their inventory. And they have the main access driveway to the business right on that eastbound ramp that goes over the bridge. And then at the southeast side is a residential condo community, and that's actually protected by a large or pretty steep embankment that you can kind of see in the plan view. And this area was protected by that embankment that surrounds the community. So none of the homes were flooded. The bridge was actually widened in 2014. This is the general plan and elevation from that contract. In the plan view, the blue highlighted area is the portion of the bridge that was widened in 2014. The southwest approach retaining wall, which failed during the hurricane, is highlighted in red in the elevation. And that's the retaining wall that failed during the storm. The bridge and the wall are both on shallow foundations, and then there's a concrete invert slab in the stream that was installed for scour protection. And then there's an existing 24-inch sanitary sewer main that runs below the wall. And then these are just some existing details of the wall. So it's a prefabricated modular wall with, like I said in the previous slide, with a step bridge foundation. And then there's a parapet and moment slab that goes on top of the wall. WSP was contacted by NJDOT on September 2nd, the day after the storm, to assess the damage at the site. And as you can see, the retaining wall at the southwest corner of the bridge failed. In addition to that, that 24-inch sanitary sewer main below the retaining wall ruptured, and then they had to bypass that line by making a connection to the pipe upstream. Water levels during the storm were about 10 feet above the roadway, which I have like a line above the bridge that kind of shows you where the water levels were during the storm. Just like the embankment in this area was completely eroded at the southwest side and the southeast corner. This is kind of a zoomed out photo of that same elevation. You can see there's a utility pole above, and that was undermined within the limits of the retaining wall that failed. These are just some additional photos from on top of the bridge. So the photo on the left is the pre-storm conditions at the southwest approach. And then the photo on the right is what we saw when we went out there on September 2nd. So that parapet and moment slab that was on top of the wall was kind of spanning 40 feet between a couple columns of the precast wall that remained adjacent to the bridge, a portion of the wall at the east side that still remained. And these are a couple additional photos from below the bridge in that area. You can see all the backfill from behind the wall have been flooded out, and then the roadway approach slab for the southeast approach was undermined. These are just a couple additional photos from on top of the bridge. That's a closer photo of the utility pole that was undermined, and then the ornamental railing on top of the parapet was just completely warped out of plane. And these are some additional photos of the roadway above. We can see tension cracks in the pavement where the failure plane was for the backfill below the roadway. This is a photo of the southeast embankment. So the retaining wall at this side didn't fail. All of that riprap was previously close to the bridge and it floated about like 30 feet downstream. And the embankment was pretty chewed into on this side as well. These are the full height concrete abutments at the upstream north side of the bridge. So these were built as part of the original construction. And we just thought it was interesting that something so robust was at the north side, whereas something, you know, they have like the step shallow foundations for the precast modular wall at the south downstream end. Getting into how the project progressed, so we had the immediate response field visit on the 2nd, and that was followed up by a site visit on September 5th with NJDOT there, the designer, us, the on-call contractor, county, and the utility companies, PSE&G, and the sewer authority. And that's kind of when we decided on what we were going to do for the immediate repairs. And immediate repairs were decided on through field direction and sketches that could be kind of communicated electronically to speed things up. And then from there it was just regular meetings and constant coordination with NJDOT operations and the structures and geotechnical subject matter experts at NJDOT. And then to expedite the project, NJDOT also allowed electronic delivery of submittals and shop drawings, and then on our end we were turning shop drawings around like within a few hours or that day. And then for work later on, they also approved electronic delivery of design drawings and plans. And then on our end, we were coordinating with fabricators and the contractor on material availability, and just making sure that the fabricators knew that this was an emergency situation and we needed the shortest lead times as possible. How the project was phased out. So on September 2nd, that Route 22 eastbound ramp and the access driveway to the car dealership were closed to traffic. So at that point, there was a lot of urgency to get that roadway reopened. So the immediate repairs that were performed were the sewer main rerouting and relocation, or replacement, sorry, and then relocation of that utility pole that was undermined. And then for phase 1, that included reconstruction of the retaining wall and approach slab, because that had to get done before we could reopen the ramp. And then for phase 2, which could be, all of that could be done offline after the ramp was reopened to traffic, that included reconstruction of the parapet and moment slab, stream bed armoring, and the concrete invert slab repair. This is a photo of the sewer main relocation, that first photo of all the damage. They initially bypassed the line, but then they came back, and within a few days they replaced the pipe that failed and installed a couple new manholes to tie in the connection to the sewer main. This is a photo of the completed utility pole relocation. So for the utility pole that was undermined, they had just installed 2 new poles on either side of the pole that was undermined, relocated the wires to the 2 adjacent poles, and then they were able to remove the damaged pole. This is one of our preliminary sketches for the phase 1 repairs. So as part of phase 1, the contractor had to demo out any remaining portions of the parapet, railing, damaged wall section, and approach slab. And then we proposed reconstructing the failed wall with a wire mesh retaining wall system, and then reconstructing the roadway approach slab above. The idea was to kind of do something that could be installed quickly, so this required 2-phase construction of the wall. So the wire mesh portion of the wall could be installed, again, pretty quickly, and then they could come back after traffic was reopened and install the precast panels for the front facing with a closure port to tie it into the wall. After the retaining wall reconstruction, the ramp could then be open to traffic. And I guess some differences between this and the existing wall is that we kept the footing at a lower elevation, and then we're also proposing armoring the embankment in front of the wall. Another thing is, I guess, the reason why we didn't consider sheeting or anything for the retaining wall system in this area is just because of site constraints. There was a lot of concern about damaging that ductile iron pipe, the sewer main running below. So any large vibration could potentially damage it. And then we had equipment restrictions due to those high power electric wires above the bridge. And these are some photos of the completed phase 1 work after the wall was installed and reconstruction of the approach slab. We did run into some issues during phase 1. So about 1 month after Hurricane Ida hit the area, there was another storm that reached 100-year flood levels, so like right up below that, the fascia beam of the bridge. And during that storm, water washed away all the backfill in front of the partially constructed wall, and it was undermined. The photo on the left is the wall after that repair. Basically, the contractor had to reconstruct the last 15 feet of the wall, and then they reinstalled backfill, and then they put that large diameter stone along the stream bed to prevent any washouts in the future. While we were out there looking at the retaining wall repair, we sounded underneath the existing bridge footing in the concrete invert slab and found that there was a pretty large scour hole below that. And that was further verified by like a diving inspection, and they found that there was a 6-foot scour hole along the full length of the slab. This is a photo of our detail for the concrete invert slab repair. Basically, they installed grout bags along the perimeter of the slab and then backfilled with large diameter stone on top of that. And then grout tubes were used to access the scour hole so the grout could be pumped into that void from equipment positioned on the embankment. These are some additional photos of the phase 2 repairs. So the photo on the left is just the precast panel installation right before they did the first lift of the closure port. Photo on the right is the repair after the concrete invert slab work. Phase 2 repairs for the stream bed armoring, that's actually going to get done a little bit later this month. We're proposing marine mattresses to restore the embankment. These are a 12-inch thick geogrid material that get backfilled with stone, and then they're tied in at each end with by being embedded into riprap about 3 feet deep at each end. We're also proposing like that tie-in detail photo, just large diameter stone along the stream bed. And the limits of the repair are going to be about 100 feet downstream of the bridge and then 50 feet on either side at a 2-to-1 slope. Just wanted to thank NJDOT for the opportunity to work on this project, as well as helping us to expedite everything as we move through. So if you guys have any questions.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.